cities are more than just the places we live. They function like living organisms, dynamically growing and changing over time. Any decisions made in city planning can either improve or degrade the health of urban spaces. Advanced digital approaches involving data-driven modeling and visualization now offer architects, engineers and construction professionals new ways of understanding how cities function and predicting how changes in their design could affect lives. Digital twins improve the planning and construction process to make it as time and resource efficient as possible. Digital twins can improve environmental performance and productivity of individual buildings and asset infrastructure once in operation. Feeding the twins information into advanced analytics and data models gives operators the ability to undertake predictive maintenance, minimize downtime, and identify potential problems. The growth and convergence of technologies like the cloud, artificial intelligence, machine learning, 5G, and IoT are propelling digital twins to the forefront of AEC industry and city infrastructure management, with geospatial technologies as the enabler. Welcome to the symposium on AEC and Digital Cities.
We'll go ahead and begin the session for the day, AEC and Digital Cities. So we have witnessed a level of digitalization like never before over the last year and a half, mostly due to the level of remote project workflows that had to be undertaken, be it in terms of digitalizing plan and design or the conceptualization stage, or all the way to your operation and maintenance. The role of digitalization using geospatial technologies, as well as digital twin for that matter, has seen a surge like never before in the last 5 years. I'll just quickly walk through the type of impact that COVID had over the global building construction market in the year and a half since the pandemic began. A lot of construction sites foreclosed. Around 30% of construction sites witnessed a substantive impact in terms of suspension of project on-site. Around 15 to 20% of manufacturing capacity was impacted. A lot of raw materials and supply chain had to be revamped. 20% of planned total output underwent a significant reduction. Moving on, there were not only negative impact for the industry, there were a few positives as well. The deployment and enhancement of technology seen increased uptake, especially across multiple disciplines. There was improvement in terms of material planning and management, as well as workplace design. There's a lot of encouragement in terms of collaborative and risk assessment-based project workflows. And there was an increase on off-site works, as well as other modern methods of construction like DFMA, etc. Now coming into the whole GeoBIM ecosystem and how the industry started using an integrated GIS and BIM platform, not just for your regular on-site construction progress monitoring and tracking, but across a series of other COVID-based challenges that had to be overcome. So on one hand, you had to monitor the risk associated with COVID and COVID-induced closures and on-site. And so that was done using on-site risk monitoring. So nothing new here, but the whole positioning system-based technologies, be it GNS or GPS systems, were used to track and monitor movements within the construction site. And this was particularly witnessed in the Middle East region, wherein despite the construction market taking a heavy blow, a lot of contractors and subcontractors were able to keep their projects alive. Connected construction became a whole different game altogether because they were able to understand and predict your project outcomes, not through physical monitoring on-site, but like off-site, you were able to gather your project data and project information, be it for materials, machines, or your workforce, and connect it across the value chain and the life cycle. There were other analyses that took place as well. For instance, BIM and IFC format-based data platforms, they've seen a larger uptake and significant integration over cloud and cloud-based collaboration. So what do these digitalization and digitalization solutions have in place for the overall market? And this is a data figure that caught everyone's attention during the release of the last year's McKinsey report. The whole market is bound to have a profit of around 265 billion US dollars based on these different factors and implementation of these factors. Starting off with industrialized construction, where you have a product-based approach instead of a project-based approach. Moving on, intake of connected construction solutions, so that, as we discussed in the previous slide, you are able to connect the data between machines, materials, and workforce. Digitalization of products and processes, especially to make sure that you assess the level of uncertainties and risks that are taking place both on-site and off-site. And of course, there is a level of standardization required for the project data, both in terms of data collection and data processing and analysis, so that every stakeholder associated in a project across the value chain is able to access and use and modify the data accordingly. I'll just quickly walk through the technological evolution that we have foreseen in the last couple of years. And it's interesting, in the last week or so, we saw the release of ArcGIS GeoBIM. So a lot of leading technology providers are coming out and they are realizing the need for integrating these different digitalization measures, because data in silos, especially for an industry like construction, never would be able to help envision the type of solutions in terms of sustainability, in terms of risk reduction, and moreover, reducing your cost and time overshoot that predominantly plagues this industry for a lot of decades. In terms of technologies, again, like, there has been a series of increase in terms of mergers, acquisitions, and partnerships. Especially since 2018, we have seen a surge in multiple big companies coming together, encouraging startups and other initiatives with smaller and medium-sized companies to make sure that all these indigenous solutions are scalable and can be adopted across different regions of the globe. So a few main players, like be it Autodesk, Faro, Bentley Systems, and Trimble, they've been engaged in larger uptake of mergers and acquisitions and partnerships in Q3 of 2021. So this is an in-house research that Geospatial World has been conducting in terms of understanding and basically mapping the type of technologies to make sure that a user, or an end user for that matter, is able to move forward in applying these different technologies across the project life cycle. So we were able to devise a mechanism wherein we are able to put together technologies from a very foundation level, be it total stations, CAD, or BIM models, to digitalized elevation models, and connecting that across the different stages of your project life cycle. So as you see in the graph over here, we are trying to understand on the x-axis the level of collaboration that is taking place, the type of stakeholders who are connected through these different mediums of technologies. And over the y-axis, we see the level of maturity as they drive further with this different adoption. Now, it isn't necessary that a small or medium-sized project needs to apply every single technology in this particular graph, but it is necessary to digitalize every part of the project lifecycle, irrespective of the scale of the project. So overall, we have 3 stages of the GeoBIM maturity model, from amateur to sophisticated. And towards the sophistication, we see the inroads for different 4IR technologies like LiDAR, GPR, digital twin, integrated BIM, GIS, and IoT platforms, and other forms of off-site construction, including prefab or modular construction. Moving away from the technology, we can also assess the level of maturity in terms of the digitalization which happens within the project workflows across different project life cycle. If we have to divide the entire project delivery and execution mechanism within the maturity model, we can divide it into 2 parts: the project planning and delivery side, and the asset inspection and management post-project handover. So we start off with your basic schematic design, project plan modification to your data exchange and sharing. But we move on, we build on these data to make sure that we are able to document these data properly, and then we are able to project the level of effort and cost required, the level of time that is required. And how do you monitor these projects? Like, how do you predict the different type of maintenance that is required? And that allows you to mature up the ladder of process-based GeoBIM maturity. So finally, we would like to see your end users able to track, trace, and monitor the different types of project workflows that are happening across the project lifecycle. We would also like to see the end users reduce their physical connection on site and leave it up to the technicians who are only required to stage their machines or materials, and use as much offsite monitoring and inspection as possible, and that way you're already reducing the emissions and energy consumption required to go check these sites, and also you're able to have a transparency across the project life cycle to every stakeholder who was involved. This is a survey that we did this year from summer till fall. It's around 300 to 400 odd survey responses, and this is what we realized. This is what we realized in terms of the project benefits when we talk to the end users in terms of adopting an integrated GIS and BIM workflow. There's improved project forecasting, there's improved collaboration across the team, there's reduction of RFIs and change orders, and there's less time searching and validating information. So these are some of the challenges that the end users feel and believe that an integrated GIS and BIM platform can help them overcome. Now, in terms of a business-related benefit, you can see that around 72% of the end users have cited an improved client satisfaction, and a sub-factor within that is the level of transparency that we were just talking about. There's also an improvement in terms of repeat business from existing clients because A, you are able to reduce your wastage, your cost overruns, and B, you are able to meet the target deadlines within time because you are on top of the projects throughout the course of the life cycle. Coming back to the GeoBIM Readiness Framework, now how do we assess GeoBIM readiness? Like, now, how do you assess a project or a region, for that matter, in terms of their readiness? So the Geospatial World research that we had done took into account 3 major pillars in terms of the user adoption, the policy framework that is in place, and industry offering. Now, in terms of the policy framework, we've got BIM adoption framework. We have standards and guidelines indicative of the level of BIM that needs to take place in different stages of the life cycle. When it comes to geospatial technologies and the niche solutions that are formed through geospatial technologies within the construction site, there are rarely such guidelines, and that is something that the larger think tanks or the government bodies or development agencies can work on. Beyond that, in terms of the industry offering, so we have major players globally who are able to produce and churn out these features and capabilities, looking into various challenges across the project lifecycle. But at the same time, the advent of the application in terms of the small and medium-sized companies in developing region has been very less. So that is something that the technology providers can look into and figure out how to make inroads in terms of increasing the adoption level in these developing regions. So we went ahead and mapped the GeoBIM readiness for around 25 countries, and these are the top 10 countries in terms of their user adoption and industry offering and the policy framework. So we can see that in terms of user adoption, China is leading the race. They've been able to increase their infrastructure spending. They have had multiple stimulus packages to improve their transport infrastructure, increase their housing and building construction as well. And that's thanks to their application of be it BIM or GIS or any other 4IR technologies at the earliest, during the early stages of their projects itself. But otherwise, you can see a lot of Western regions taking over in terms of the industry offering and the policy framework, which is a good sign. But other than Singapore and China, you can barely see any other Asian countries, and that says a lot. So that's my introductory remark for this session. Thank you so much.